Hello Legacy students, Marsh here. So today we're going to factor a quadratic equation. You're going to want a pen or a pencil. You're going to want that flip book that we got in class, or make sure you download it and print it. You need maybe a calculator just to do some multiplication, and then you're going to need your thinking cap today just to keep your on your toes. Do you know how to multiply? You should already. This is not new stuff. Basically it's foiling, right? That times that, that times that, that times that, that times that, right? Same thing with x plus 3x minus 3. Well, basically, guys, what we're going to do today is undo multiplication. That's all that factoring is undoing of multiplication. So go ahead and open your first flap where it says factor. What does it mean? So under the two bullets, the first bullet is to find out what was originally multiplied to create the expression. So that's what factoring allows us to do. It lets us to figure out what was originally multiplied, aka it undoes the multiplication process. So that's ultimately what we're doing when we're factoring. Consider it being the undoing of the distributive property. The most common kind of factoring is known as greatest common factoring. So basically finding the greatest common factor. On the top part where it says the bullet, you want to put what is the largest number and or variable that can be divided out of each term in the expression. Ultimately, that's the question that we're going to want to ask ourselves as we are factoring out the greatest common factor. And I have 3 problems to work on with you. So here we have the first example. I want to see what's the largest number and of variables that we can divide out of each of them. Now, you can't just take one out of 2 of them. You need to have it so that they all share it equally. So I have 6, 12, and 18. So the number that I can divide into 6, 12, and 18 is 6, right? That's the largest number. Yeah. So if I divide each of them by 6, and then also I'm going to look at the x's. But now notice this guy has 2 x's because it's an x squared, an x, and this guy doesn't have an x. I cannot divide by x then, because this 18 does not have an x to give. So the largest number I can divide by is 6. So what I'm going to do is I'm going to show that I factored out the 6, aka I divided it out. So if I divide 6 into all these, I'm going to get 6 divided by 6, that's 1x squared. Negative 12 divided by 6 is negative 2x. And 18 divided by 6 is 3. All I did is I divided by the greatest common factor. Now, best thing about factoring is I can multiply this 6 back in, and I should and will in fact get back to the original problem. That is something, if you wish to check your work as you go for it. Let's look at this second example here. It looks like the biggest number I can divide into 14 and 7 is a 7. Now if I look at the x's, this guy has 4 x's to give. This guy has 1. So the largest number of x's that I can divide out of both of them is 1x, right? So it looks like my greatest common factor of 14x to the 4th and negative 7x is just 7x. So what I need to think in my head is I need to divide by 7x. What's going to get left behind? AKA, what times 7x gives me 14x to the 4th? Well, 7 times 2 would give me 14, right? And I divided by 1x, so x to the 4th divided by an x, I still have 3 x's left behind, right? And then I have negative 7x divided by 7x. So negative 7 divided by 7 is a negative 1, and the x's are going to cancel, meaning I'm left with just a negative 1. Let's look to example 3. Notice, guys, there is some x's and y's. Don't be afraid. It's going to be all right. Biggest number I can divide into 28, 16, and 8. Not 8. but 4. 4 will go into all of them. Let's look at the x's now. This one has 2 x's, this one has 5 x's, and that one has 1 x. Biggest number of x's that each one of them can give is only a single x. Womp womp. Looks like 1 y as well, right? Looks like I have 7x left behind because we don't have any more y's, right? Because we divided by that y. 1x left behind. 16 divided by 4 is 4. 5x's divided by 1x is 4x's left behind. No y's. 8 divided by 4 is 2. No x's left behind, but this time we do have a y left behind. Now, if I do this in my head, make sure I multiply this back in. We're all good. All multiplies back to give me my original expression. Now, the next kind of factoring that you'll probably most likely attack is called group factoring, or factor by grouping. This is when you have 4 terms or 4 pieces to an expression. What you're going to do is you're going to group them into pairs, and then you're going to factor out the GCF of each group. Then you're going to factor what is in common one more time. And I'll show you what that looks like. Here are the 3 examples that we need to talk about. So notice, guys, there's 1, 2, 3, 4 pieces to each one of these problems. That's when you want to use this method, is when you have 4 pieces. So what I'm going to do is I'm going to group these 2 pieces here, and I'm going to group these 2 pieces here. I'm now going to pull out the GCF of each of the 2 pairs I have made. So 2x cubed plus 12x squared. What I need to do, it looks like my GCF is a 2 at the very least, and then x squared, right? Yeah. So if I would divide just this piece by 2x squared, I will get an x and plus 6, right? Now, originally, these 2 pieces, these 2 pairs, were together, so I'm going to put an addition sign in the middle, because they technically were added here. We just kind of broke them apart, if you want to consider it that way. Let's now factor out the GCF right here. It looks like -5 is common between these 2, right? And then it looks like I'm going to get an x, and then -30 divided by -5, that's a plus 6. Now, notice, guys, something is in common with these 2 things. I want to factor out what's common one more time. Notice x plus 6 is common of these 2 factors. Because all these are just factors right here. So I can pull out the x plus 6. What's going to be left behind if I divide this by x plus 6 and this by x plus 6? Well, I'm going to be left with a 2x squared and a -5. That is my final answer. That is me factoring by grouping this polynomial. Let's try it again. So I'm going to pair these 2 guys. It looks like the GCF of my first pair is 2x squared. I got an x and plus 2 left behind. Now, just like last time, we did technically add this, so we do have to have an addition sign there. An x plus 2, you're probably thinking, well, Marsh, there is no GCF. They don't share anything. Technically, they do. If there is nothing to be pulled out, you need to put a 1 there. Technically, you can factor out a 1, because factoring out a 1 doesn't change anything. Okay? And then I'm going to just be left with x plus 2 yet. Now, notice, guys, this should always happen. You should always get something that are alike. If not, most likely either A, you divided wrong, or B, you didn't take out the biggest GCF that you could. Same thing, I'm going to factor out the x plus 2, and I'm going to be left with the 2x squared and the plus 1. Let's try one more time. So group. It looks like it's going to be a 3x for this piece. I'm going to have 4x and then plus 3y. plus, because remember it was originally subtracted but technically added. It looks like both of them have a negative, so we can do a -1, and then they both have a y as well. So -4 divided by -1 is a 4, and then we got the x left behind. Divided by -1, so plus, and then we have 1y left behind. Notice, guys, got another match. Worked perfectly. So if I factor that out, I'm going to be left with 3x minus 1y. Ultimately, guys, what this is doing is undoing the distributive property, if you want to consider it that way. That's pretty much all you're doing. Now, what if you have 3 terms? This is kind of the common factoring that you normally will see. So what you're going to do is you're going to take the a coefficient times the c, which is your constant. Then you're going to ask what multiplies to make that number that we just got when we did a times c to add up to that middle term. Then you're going to turn it into a 4-term grouping problem. Let's try 3 examples of this as well. So what you're going to do, you're going to take the a term, which is right here, the front piece right there, and multiply it by the c term, the back number, the one with no x. So I'm going to go 1 times 6, and that is going to give me 6. 1 times 6 gave me 6. Now, I'm going to ask myself, what 2 numbers multiply to give me 6? Or what numbers multiply to give me 6? Well, we got a 2 and a 3 and a 1 and a 6, right? Now, which of these pairings add together to give me this 7? Well, 2 plus 3 is 5. That doesn't work. 1 plus 6, that is in fact 7. So this is the piece I want. Now, what you can do is you can expand to that middle term. You can make it into the 2 pieces. So I can make this middle term here not just 7x. I can make it 1x plus 6x. Right? Because that's just 7x. Consider it basically undoing the combining that you normally would do. Then I still have this plus 6 hanging out. Now, it is now a 4-term grouping problem. I can do this. These are the problems we were just doing. So I can group. Looks like an x is common. Plus, looks like a 6 is common. Factor out the x plus 1 out of both pieces, and I'm left with a x plus 6. Done. So once it's a trinomial, what you need to do, expand that middle term, make it a 4-term grouping problem, and then just go with grouping. Let's try it again. So I got a 1 times a -16. So I got -16 for my number. So numbers that multiply to give me -16. Well, -1 and 16. 1 and -16. 4 and -4. 2 and -8. Oh, look, guys. Hold on. Before I keep going. That is -6, right? If I add 2 minus 8, that's -6. Perfect. So now I can expand this middle term into 1x squared plus 2x minus 8x minus 16. Notice 2x minus 8x is just -6x. Let's do our grouping. So it looks like an x is shared. Left with an x plus 2. Add on, looks like a -8 is shared. That would be an x plus 2. Factor out my x plus 2. And I'm left with x minus 8. Now notice, guys, if your a is 1, right here, notice how these are just the numbers. Okay, that is something that you can do. If your a is 1, you can just take the 2 numbers and place an x in front of there. If it's not, that doesn't work. But if your a is 1, you can take these 2 numbers, bloop bloop, and just plug them in with an x, and that will be your factors. makes your AC method, especially when your A is 1, a lot quicker. And we need that by the end of the year. We need to be very quick in our factoring. Let's try one with an A not 1 then. So I have a 3 times -2, that's -6. And now I need numbers that multiply to give me -6, but add together to give me the middle term, aka 1. 6 and 1, that will give me 5. 3 and 2. Now which one has to be negative? -3 plus 2, that'll be -1. That's not what I want. I want a -2. So 3 and -2. So what I'll do is I'll span my middle term. -2x minus 2. Okay, now I need to do some grouping. So 3x, looks like it's an x plus 1, right? Because 3x divided by 3x is 1. It's not nothing. Add on. It looks like I'm pulling out a -2 here. Left with an x plus 1. Yep. So I will have 3x minus 2, x plus 1. Notice, guys, the trick that works for a equaling 1 does not work when your a is not 1. So be very careful. Watch out for that. Do not try to go trick galore, because you will be very sad when it doesn't work. Last one of factoring, difference of perfect squares. Here's what you're going to do. This is when you normally have 2 terms, but there's a kind of a gotcha moment that you need to worry about. You need to identify if you have each of the following before you use this method. You need to make sure you have a difference, aka 2 terms subtracted from one another. You also need to make sure you have perfect squares. So each term, both 2 terms, need to be perfect squares, aka 4, 16, 25, 6, 36, any of that number. Then you can use it into 2 factors, one with a positive, one with a negative. It's actually super simple. Let's look at a couple of examples here. So I got x squared minus 49. Here's what you're going to do. We're going to make sure both of them are, there's a subtraction, good, and both of them are perfect squares. X squared is, that's x times x, and 49 is 7 and 7, right? So here's what's going to happen. You're going to have 2 different factors, one with a plus, one with a minus. Now, what 2 numbers multiply to give you x squared? X and x, right? 49, same number, 7 and 7. Now you're saying, how do you know it has to be the same? Here's the thing. Do you see how we don't have this middle term in the middle? We have 0x. Well, if I multiply this back out, I'm going to get x squared negative 7x plus 7x minus 49. Notice, the middle term cancels. That's why we need it to be the same number in the front and the back. Just the plus and the minus changed, because that will cancel out our middle term, making it easier for us to factor. So that's something to keep in mind. That's why we know it's going to be at the same number on both of them, or that it's going to look exactly the same except a plus and a minus. So let's look at the next one here. I got 4x squared minus 9. I have a difference. They are both perfect squares, so this will work. 4x squared, same thing written together. Well, it have to be the same. I know it's going to be an x and an x, right? But it is 4. Well, that would be 2 times 2, right? That would give me 2x times 2x would give me 4x squared. 9 would be 3 and 3. So ultimately, all you're doing, guys, you're technically taking the square root of both of those, if you want to consider it that way. Much quicker that way. I have 2 perfect squares of subtraction. This one's set up just a tad bit differently, but that's okay. 81, square root of that, that's 9 and 9. One with a plus, one with a minus. Then w squared, that would just be w and w. These are super simple, but a lot of students forget to watch out for these guys because you get so used to AC method and you just kind of forget of how to do these. If I do this one as well, I can square root that, square root that. Looks like it's going to be a 4x on both of the fronts, and then a 5. This one, I have a difference. They're subtracted. A perfect square here, but 7 is not a perfect square. You know what? This is not factorable. Can't do it. Doesn't work. 7 is not a perfect square. I would have had to have 16 or 49 or something there. Now, sometimes you need to take that GCF first. That's always something to keep in mind. Always look for a GCF. So it looks, guys, that I have a 5 common between those two. So I'll have an x squared minus 4 if I divide out that 5. Notice, guys, now x squared minus 4, that is a difference of perfect squares. So that is 5, x plus 2, x minus 2. Done. So you need that GCF first. Just like this one, I have a 2, and it looks like they actually have an x in common as well. So let's yank that out. We'd be left with an x squared and a 36. So if I factor further, we'll get x plus 6, x minus 6. Not too bad. These are probably the easiest, but they are the easiest to forget about as well. And that's the end of this video. See you later, Sabers.